Welcome to multiple choice question 15 of the 2008 Mathematical Methods Exam 2. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of a CAS calculator is not really appropriate for this question, although you may wish to consult your notes when questions like this appear on an exam. So for question 15, we consider the sample space when a fair die is rolled is 1, 2, 3, 4, 5, 6, with each outcome being equally likely. And the question goes on to ask, for which of the following pairs of events are the events independent? So this was a particularly challenging question in the exam, which you'll see by the examiner's report at the very end. So we're going to work methodically through this one. So the first thing that we need to identify is that if A and B are independent, then the probability of A intersecting B is equal to the probability of A times the probability of B. So that's something that we know is true for independent events. So what we're going to need to do is work through the 5 options given and work out which of the options satisfies that relationship for independent events. So for option A, this is how we're going to work through it. I'm actually going to let the set A equal, in squiggly brackets, the 1, 2, and 3. So that's just that first set that's listed. Set B I'm going to have as being the list of 1, 2. So that was the second one given in option A. And from there we can work out that the set of A intersecting B, so the elements that are common to both, are the 1 and the 2, because they're listed in both events. So we're going to have 1, 2. So from there, we can work out the probability of each of those events. So therefore, the probability of A occurring is 1, 2, 3 outcomes out of 6 that are all equally likely. So that simplifies to a half. For B, we would find the probability of B is 2 outcomes out of total of 6. So that is 1/3. And without using this formula initially, we can just see that A intersecting B has 2 events. So the probability of A intersecting B is equal to 2 out of 6, which also gives 1/3. So next we perform the test for independence. And that test is just checking if the probability of A intersecting B does in fact equal the product of the probabilities of A and B. So we're going to do the probability that A intersecting B is equal to, and first up we'll take the probability of A, which is 1/2. So we'll do 1/2, and then that is multiplied by the probability of B, which is 1/3, and we're going to evaluate that, and that is equal to 1/6. However, we now need to compare that against the value that we actually know is the probability of A intersecting B, which is this 1/3 down the bottom. So we can see that 1/6 does not equal the 1/3, which is the actual probability of the intersection. So therefore we conclude that these events are not independent. So we can strike A off our list. So now we'll move on and have a look at option B. So for option B, we're going to go through all those same steps, but I'm just going to speed it up by getting these to just appear for us. So A is going to be 1, 2. B is the set of 3, 4. So again, they just come from the events that are given in option B. The intersection of A and B, though, is the null set. There's no elements that are common to those, so we can use this little symbol here to represent the null set. And then working out the probability of A is 2 outcomes out of 6, so it's 1/3. The probability of B is also 1/3, and the probability of A intersecting B, because it's the null set, is 0. So we test for independence, and we get 1/3 times 1/3 equals 1/9, which is not equal to 0. So that's the same test that we did before. So we conclude that those 2 events are not independent. Doing the same thing for C, we set up that event A is going to be the first list in C, event B is the second list in C, and the intersection of those 2 events is just the outcome 1. So the probability of A is 1/2, the probability of B is 1/2, and the probability of A intersecting B is 1/6. We then test for independence. We find 1/2 times 1/2 is 1/4, which is not equal to 1/6. So they are not independent. For D, we'll do exactly the same thing again. So we're going to have event A is 1, 2, which is the first list that's given in option D. B is 1, 3, 4, 6, which is that second one in D. And then the intersection of those two is just the outcome 1. So the probability of A is 2 outcomes out of 6, so it's a third. Probability of B is 4 outcomes out of a total of 6, so that's 2/3. And A intersecting B is 1 outcome out of a possible 6, so it's 1/6. And then we test for independence, and 1/3 times 2/3 equals 2 on 9, which is not equal to 1 on 6, so A and B are not independent. So that leaves us with option E, which hopefully I'll be able to show are independent. So we're going to work through this one again. So A is going to be the set of 1, 2. B is going to be the set of 2, 4, 6. And that means that A intersecting B, we can work out any common elements, which is just the 2. So that is the set of 2. So therefore, the probability of A is going to equal 2 out of 6, which simplifies to be a third. The probability of B is 3 outcomes out of 6, which simplifies to be a half. And the probability of A intersecting B is 1 event out of 6, which doesn't simplify. So then we test for independence. So here we're going to do the probability of A intersecting B is equal to, and we start with the probability of A, which is 1/3. Then we multiply that by the probability of B, which is 1/2. And we work out that that is equal to 1 on 6. And in this case, that does equal the actual intersection of A and B, which is also 1/6. So because that equals the actual intersection's probability, we can conclude, therefore, that the set 1, 2 and the set that is 2, 4, 6 are independent. So that means that E is the correct answer for this question. So the reason why I took so long to go through that problem was I did really want to highlight how you have to approach a problem like that, because only 7% of students got this question correct, which is one of the worst multiple choice outcomes that I've ever seen on an exam. And in fact, 62% of students all thought that B was correct. And the reason they thought that B was correct is they confused independent events with mutually exclusive events, which is a really common mistake on exams. So if you want to work through a problem like this and work out which two lists or two sets are independent, you have to go through and test them like I showed. Now, you may be a little bit quicker than the way that I went through it, and you might be able to even rule out some options, like a mutually exclusive set of events. You wouldn't actually need to test that one. But you need to be able to go through and do a problem like that for these exams.